Good evening. So, am I audible?
Yes, sir.
Okay. So, in the last class, we started with binomial theorem. So, these questions you might have done. So, I will solve it. Okay. So, in detail. Otherwise, I know you must have solved these questions. They were easy. Okay. So, at the same time, most of you solved this. So, what can we do? Let's solve first this, then we'll continue. So the first question was, using binomial theorem, what is the remainder when this is divided by 25? So in exam, if this question is asked in entrance exam like JEE, suppose they ask, or any entrance exam, so you don't have to prove it. Okay, you just put different n and you try. Like you put n is equal to, suppose start with 1. So you put n is equal to 1 and see what happens to this. So 6 raised to power 1 minus 5. So what will it come? It will give you 1. 6n minus 5n is will give you 1 when n is 1. So what is remainder when divided by 25? So 1 will give remainder what when divided by 25? So it is 1 only, isn't it? Okay, so 1 get this. You put n is equal to 2. So it's a 6 raised to power n minus 5n will be what? 36 minus, and actually since this question is true for every n, okay? So this holds for every n, so it will not affect, right? It is not for some n, it is for all n. कितना आएगा? 36 minus 10.
10.
Yeah, so 26. And what is remainder when you divide 26 by 25?
1.
It is 1. So in this way you can get intuition, okay, what should be the answer, because this holds for every n. So if holds for 1, if answer is 1 for this, then 1 will be for every, because this is in general question. Okay, what is the way? Suppose in your school exams or college exam they ask you, in subjective question you have to solve it. So how will you solve? So in that way, let's start. So we have to prove that remainder when 6 raised to power n minus 5n is divided by 25. So let's start with 6 raised to power n. Okay, so first question I'm solving. So 6 raised to power n. So what can you write it? You can write 1 plus 5 raised to power n, and 6 raised to power n you can expand it as, so since we know that 1 plus x raised to power n is equal to 1 plus, so I want to use the formula, this one, 1 plus x raised to power n is equivalent to NCR x raised to power r from 0 to n. So let's use this. So it will be, okay, let me write like NCR 5 raised to power r from 0 to n. So when you open this, 6 raised to power n is like NC0 5 raised to power 0, NC1 5 raised to power 1, NC2 5 raised to power 2, then NC3 5 raised to power 3. Okay, and it will keep going to the last term, NCN 5 raised to power n. Now you have to remember the question. So what was the question? Question is, what is the remainder when 6 raised to power n minus 5n is divided by 25? So means they want to ask, when you divide, so what is the question? So question they ask you in general. So in general they mean that 6 raised to power n minus 5n when divided by 25. So 25 is the divisor, q will be quotient, and r is remainder. So we are interested in r. We are interested in this remainder. So what is the remainder when we divide 6 raised to power n minus 5n by 25? So r is the remainder. So I would like to convert this. So let me simplify one term. So NC0 is 1, you all know. NC1 is n, and it's a 5n. And in the rest term, what do you see the common in the rest term from here to here? What is the common?
5 raised to power 2.
5 raised to power 2. So 5 square you can take common. you will get some numbers. So actually we are not interested in quotient. So what I want, I'm just naming them Q. Are you getting my point? Because we are just interested in
Yes.
remainder. So if you want, you can write it, no problem. So it will be like NC2, then NC3 into 5, because 5 square is taken out, and plus so on NCN 5 raised to power n minus 2. So what I said, I'm interested in 6n minus 6 raised to power n minus 5n. That we get as 5 square is 25, and I name this whole quantity as Q. So I rename, because we don't care about is this, because we only care about remainder, and plus 1. So are you getting what I'm doing? 5n I took on left side, 1 is here, and 5 square is 25. That is quantity I named as Q. So what do you get here? You get that 6 raised to power n minus 5n is 25q plus r. Okay, so r you get is nothing but, okay, so what you get, 6 raised to power n minus 5n is equal to 25q plus r. And you know the this formula, right? Dividend is equal to divisor into quotient plus remainder. This is called Euclid's algorithm, okay, or Euclid's formula. So dividend is equal to divisor into quotient plus remainder. So in place of remainder we have 1. So answer is the remainder will be 1. So what I used binomial theorem. Where I used binomial theorem? In the expansion of this 6 raised to power n. So tell me, do you have any doubt in this?
No, sir.
No,
Okay, everyone got it? Okay, so this solved. Now what is the value of this? This is very trivial, okay? This is just trivial, since we know that we had the identity. Look, so we have the identity 1 plus x raised to power n is equal to NCR x raised to power r. Fine. So you compare the right hand side and r from 0 to n. So compare your right hand side with this. So what do you see? So I repeat the above formula. So it is summation NCR x raised to power r from 0 to n, and that is 1 plus x raised to power n. Okay. So this is the same formula. Why I'm writing again? Just to you can compare the question with this. So question you have summation NCR 3 raised to power r from 0 to n. So you can simply see that, oh, x is 3 here. So our answer will be 1 plus 3 raised to power n, and that will give us 4 raised to power n. Answer is 4 raised to power n. So that is very trivial. Okay, directly straightforward on the formula. Now let's come to the third question. So the third question is what? When 9 raised to power n plus 1 minus 8n minus 9 is divided by 64, then what is the remainder? So again, this is similar to the first question. We will try to expand 9 raised to power n plus 1 using binomial formula. So okay, let's try this. So 9 raised to power n plus 1 minus 8n minus 9. So I think you know the answer. So tell me, what is the answer?
0.
Okay, 0. Fine. So you can check, you can take n is equal to 1, and then you can check, because this question is true for all n. So for one n, whatever number you get, the same number you will get for every n, because this question is in general correct. Okay. So this holds for all n, and your answer will be unique for all n. That's why you put 1n in entrance. But in subjective exam, if they ask you to write the solution, so in that way you have to write like 9 raised to power n plus 1 means 1 plus 8 raised to power n plus 1. Again, I will use the same formula. So formula we have is 1 plus x raised to power n is summation NCR x raised to power r from 0 to n. But here you see, in place of n we have n plus 1. So no problem. Everywhere n will be replaced by n plus 1. Everywhere n will be replaced by n plus 1. So n plus 1 CR you have now. Okay. So we had formula for n. Now n will be replaced by n plus 1. So let's simplify this. So now what do you see? Summation n plus 1 CR, and r is 8. I mean, sorry, not r is 8, x is 8. So x raised to power r, and r varies from 0 to n plus 1. So using this formula, I expanded this. So in place of x, we have 8. So 9 raised to power n plus 1 is, just open this. So if you open it, n plus 1 C0 plus n plus 1 C1 into 8 plus n plus 1 C2 into 8 square, and plus this, and we can talk more, you know. So like n plus 1 C n plus 1. Last term is 8 raised to power n plus 1, because r varies from 0 to n plus 1. Are you getting point? So I just expanded this. So we used value of r 0, 1, 2, 3 up to n plus 1. So what we are interested in, what is the remainder when 9 raised to power n plus 1 minus 8n is this, and minus 9. Okay, so look, 9 raised to power n plus 1 is equal to, so you know n plus 1 C0 is 1 plus 9 n plus 1 C1, that is going to be n plus 1 into 8 plus, okay, again we see that what is the remainder when the 9 raised to power n plus 1 minus 8n minus 8 minus 9 minus 9
square.
9 is divided by 64, right? Yeah, so what I can take common from this term onwards, from this term onwards,
8 square.
8 square, right? So 8 square, if I take common, so something will come, some numbers, okay? So that number I take it as q, and that q will be actually integer, because you know NCR are always integers. So I name it q. So after taking 8 square common in the third term onwards, so the term after taking 8 square common, I renamed at q. Okay, Ji. So 9 raised to power n plus 1 is equal to 1 plus 8n plus 8 plus 64q plus 64q. And so you rewrite it minus 8n minus 9, because 1 plus 8 is going to be 9. You get 64q. So you don't have anything after this, means you have 0. So you compare it, divisor is equal to, sorry, dividend is equal to divisor into quotient plus remainder, and remainder you have 0. So remainder you have r, that is 0. So so the same way like we did first question, just same way we did this. So you got this point. So let's continue. So next what we have, so what was, we had only one formula, okay? So whatever we did in the last class, or resolved questions, so we are just using this formula, the binomial theorem. This formula is itself binomial theorem. Summation NCR a raised to power n minus r b raised to power r. R varies from 0 to 1. This is the only formula we are using, okay, in different way. So now let's go to the, so next thing is we have to find general term. So general term means if we are interested in any one term, so how we'll get that? So like, look, so if I would like to expand this, so let me expand this. So the first term you get as NC0 a raised to power n minus 0 b raised to power 0. Second term you have NC1 a raised to power n minus 1 b raised to power 1. Third term is NC2 a raised to power n minus 2 b raised to power 2. Fourth term is NC3 a raised to power n minus 3 b raised to power 3, and it is going like this. So you have NC n minus 1 a raised to power 1 and b raised to power n minus 1. And the last term is, so last term is actually n plus 1th term. You know that a plus b whole raised to power n has n plus 1 terms. So last term is n cn a raised to power 0 b raised to power n. Now so tell me, if I want to write the first term, so what I have, nc0 I'm writing separately, nc0 a raised to power n minus 0 n b raised to power 0. So what is second term? nc1 a raised to power n minus 1 b raised to power 1. What is third term? nc2 a raised to power n minus 2 b raised to power 2. What is fourth term? nc3 a raised to power n minus 3 b raised to power 3. Are you getting the point? So based on these patterns, okay, tell me what is the rth term? tr. R is any general number, okay, from 0 to n.
NCR into A n minus R into B raised to power R.
No, are you looking that? So if I write this, are you, so you have not noticed well, है ना? So your presence of mind is
NCR1 NCR minus 1 AN minus R B raised to R.
है ना? So you can notice here it is 4, so here you have 3. When it is 3, you have here 2. You can notice. So yes, that's why you will have, right? So when I'm asking rth term, so it is NCR minus 1, one less. You can notice everywhere. A raised to power n minus r minus 1 in bracket, or b raised to power r minus 1 you have. Okay. So I was asking you rth term. You know, this is the rth term. Okay. What if I ask you r plus 1th term? Yeah, what is r plus 1th term? Similar way. Okay. So you can notice here, first term is NC0, this one. Second term is this one. Third term is this one. Fourth term is this one. Okay. And this like this, it's a n minus 1th term, and this is the nth term. Sorry. This is the nth term, and last is the n plus 1th term. There are n plus 1 terms. You don't forget this. Okay, now tell me, what is the r plus 1th term in the expansion of a plus b raised to power n?
NCR A raised to N minus R B raised to R.
Yes. So this formula is convenient to use. Okay. So we'll write this as a general formula. So general term, when I say, so we'll try to write r plus 1th term, r plus 1th term. Okay. Or notation is tr plus 1. And the formula for that is NCR a raised to power n minus r b raised to power r. So you remember this formula. So this formula will treat as general term formula. So general term is, using this formula you can find any term. You want to find 1th term, I mean first term, you replace r as 0. Okay. So you want first term, you replace r as 0. So 0 plus 1 is 1. You want second term, put r as 1. You want third term, put r as 2. And or if you are comfortable with this, you can also use that. Both will give the same result. So it's up to you which formula you want to continue. You can continue with this. Okay. So this is a general term formula. Okay. So use this and solve one question. So the question is, okay, so question is, find value of a such that, find value of small a such that seventeenth and 18th term in expansion of 2 plus a raised to power 50 are equal. Okay, so are you getting the question? So you have the expression a plus b raised to power n. So a plus b is like 2 plus a raised to power 50. And 17th and 18th term are equal. So tell me, what is the value of a? Try this. So first you try 17 terms, try 18th term, and then equate both. And find both the terms, then you get equate them. No one is getting? Oh,
Wait,
Yes, I
solving.
okay, solving. Just use the above formula, general term formula.
sir one.
Okay, so one is correct. Yeah. So see, I know all of you can do. So simply you have a2 plus a raised to power 50. If you want, you can write it a plus 2 raised to power 50 because both are not different expression. Okay. So it's up to you. So if it is 2 plus a, so let's keep it 2 plus a, no problem. So I want to find 17th term, T17. So you know in T17 what will happen? It's a TR plus 1. So like you can write T16 plus 1. Okay, R plus 1. So NCR A I mean a plus b. Okay, so a is 2 and b is a actually. So n minus r, so 50 minus 16. So what will be 50 minus 16? 34. And a raised to power 16. This is the 17th term. And 18th term is, so 18th you can write 17 plus 1. So 50 C 70, 2 raised to power 50 minus 17. So that is 33 and a raised to power 70. Now, so since you have given T17 is equal to T18, okay. So you have now 50 C 16, 2 raised to power 34, a raised to power 16 is equal to 50 C 17, 2 raised to power 33, a raised to power 70. Now you simplify. So what you have now, you can cancel out 2 raised to power 33 whole by the power, so 1, 2 will be left. And here a raised to power 16 cancel out this. So you have 50 C 16 into here 2 is left side, and 50 C 70 and a is left in right side. Okay. So now you want a. So first let's simplify. So 50 C 16 can be written as 50 factorial upon 16 factorial, and 50 minus 16, 34 factorial into 2. This is 50 factorial, 17 factorial, and it's a 33 factorial and into a. So 50 factorial cancelled out, and 17 factorial can be written as, so let me write it in a better way. So I want a, so bring this quantity into numerator. So it will be 17 factorial into 33 factorial upon 16 factorial into 34 factorial. Into 2 you can take, that is a. So just simplify. 17 into 16 factorial, and the 33 factorial keep as it is because denominator is 34 factorial. So you break the larger into a smaller. So 34 into 33 factorial, and into 2 you have a. So this cancelled. Okay, 16 factorial, 17 2s are 34 and 2 cancel. So everything cancels, means 1 is left. So 1 is equal to a, right?
Yes.
So any doubt in this? That's
No.
fine. Okay, so try the next one. So those who want to see, look at once and see if you have anywhere in any step you find some difficulties. Okay, so try the next question then. So the next question is, so these type of questions they ask you in mains, and sometimes in advance also related to that. So the question is actually find the coefficient of, so the coefficient of x raised to power 6 into y raised to power 3 in the expansion of x plus 2y whole raised to power 9. Okay, so the coefficient of this is what? So I'm interested in is what? So what is the coefficient of x raised to power 6 into y raised to power 3 in the expansion of x plus 2y raised to power 9?
Sir, 84.
84. Okay. So no. So coefficient of this. Okay. So what we can do? You can first write general term. So suppose I write r plus 1th term. Okay. So formula you already know. NCR a raised to power n minus r and b raised to power r. So now n I have 9.
42, 84.
Okay, see. So you have to consider this 2 also. So that's why you are getting wrong. So x raised to power 9 minus r and b is actually 2y and 2y is r. Are you getting point? A plus b. So in place of it, this is the formula. You all know this is the formula for general term. I'm just expanding it. So r plus 1 is term I'm finding. So this is a 9cr, n is 9, and a is first term, x raised to power 9 minus r, b is 2y. So now you just compare what you need. You need x raised to power 6, y raised to power 3. So this should be 6 and this should be 3. So r you have to put. So expand this. So 9cr and 2 raised to power r you can take out, x raised to power 9 minus r and y raised to power r. Okay. So actually this is the coefficient. What you are looking, this is the coefficient. And for what you want. So you want x raised to power 6 and y raised to power 3. So this implies 9 minus r should be 6 and r should be 3. So from here you will get r3. So means when you put r is equal to 3, you will get your required term. Okay. So when you put r is equal to 3, you will get,
672.
yes, yes. So you replace r is equal to 3 here in this formula. So fourth term actually you will get 9c3, 2 raised to power 3 and x raised to power 6, y raised to power 3. So this quantity is the coefficient. Okay. So coefficient of x raised to power 6, y raised to power 3 is 9c3 into 2 raised to power 3 is 8. And 9c3 you can calculate easily. And 987.6. So use your way, whatever way you know. So it will be 4, it will be 3, it will be 3. So finally you will get answer 3 into 4 into 7 into 8. So 8 7 ja 42. Sorry, 8 7 ja 56. 56 into 12. Or you can write 56 into 4 and into 3. So multiply it. Is it, are you getting 972? I mean, what you are getting? Multiply this. Sorry, 672, na?
Yes, sir. 6.
Okay, so this is fine answer, correct answer. So when they ask you this type of question, so you just check in which term. So you can also try expand. You can also expand them. It will have 10 terms. So you have to see which term will contain x raised to power 6, y raised to power 3. And then you can decide, right? Or you can directly guess that fourth term will contain, because y has the power 3. So in the first term, y has no power. In the second term, y has 1 power. In the third term, y has 2 power. In the fourth term, y has 3 power. Okay. So you can guess. Otherwise, you can use general term method and then you compare the power of x and y. Now, try one more question of similar type. So the question is, find the term. So find the term independent of x. Independent of x. So what do you mean by independent of x? Means it is a constant term, or it will not contain x actually. In the expansion of 3/2 x square minus 1 upon 3x and whole power 6. To find the term independent of x in the expansion of 3/2 x square minus 1/3x raised to power 6. So try this. So which term, if you expand this, power is 6. So there will be 7 terms. So you have to tell me which term is independent of x. So you try in your own way, whatever way you understand, you try this. Term independent of x means there are only x in the given term. So means free of x means constant term. So first solve this question and then I will just give you one more formula. Rth term from and. So TR we know, we write it as Rth term. So Rth term actually we count it from beginning. Okay. So count it from beginning. NCR, right? A raised to power n minus R. Sorry. So I'm writing Rth term. So Rth term will contain R minus 1. A raised to power n minus R minus 1. B raised to power R minus 1.
Forty-five by 4.
Okay. 45 by
4.
no. So it is, yeah, answer is something different. So see, let me try. So one more.
15 by 16.
Not 15 by 16. It is 5 by 12. Is it? Okay, so what we need, term independent of x, means x raised to power 0. X raised to power 0 is constant 1. So first let's write general term. So first let me write the solution, then I will come to this point. Explain this. So first let me solve this. So I will write r plus 1th term. So NCR a raised to power n minus r b raised to power r.
So 5 by 12.
Yes, yes. So NCR n is 6, 6CR power is 6. Okay. And a in place of a you have 3 by 2 x square raised to power 6, and b you have, sorry, not 6, n minus r. So n is actually 6, so 6 minus r, and b you have minus 1 by 3x and raised to power r. Now see, so I have written general term r plus 1th term. So look, first let me simplify this. So 6CR 3 by 2 raised to power 6 minus r you can take out, x raised to power x square and x raised to power 6 minus r, minus 1 by 3 raised to power you can take it out, and 1 upon x. So that is, you can say x raised to power minus 1. 1 upon x is x raised to power minus 1 raised to power r. So now what you have, 6CR 3 by 2 raised to power 6 minus r, x raised to power 2 whole raised to power 6 minus r. So power will get multiplied. So it is 12 minus 2r and minus 1 by 3 raised to power r and x raised to power minus r. So since these two term has common base, so you take it together. So 6CR 3 by 2 raised to power 6 minus r, and you keep that term also here. 1 by 3 raised to power r minus 1 by 3 raised to power r. And now both has base same, so power will get added. So 12 minus 2r minus r, power will get added. So what you get the expression? So 6CR 3 by 2 raised to power 6 minus r and minus 1 by 3 raised to power r, x raised to power 12 minus 3r. So finally this is a term r plus 1 is term. So what do you want? Term free of x. Free of x means the power of x should be 0. So this power I want 0. I want that term only. So for that I want this must come 0. So r should be 4, right? 12 minus 3r is 0. You simplify this, r will be 4. So when you put r is equal to 4, you will get term free of x. So means fifth term. So t r you put 4. So t 4 plus 1. R plus 1 I will writing. You write this term. I will write this. Just I will replace r by 4. So 6C4 3 by 2 raised to power 6 minus 4 2, and minus 1 by 3 raised to power 4, and x raised to power 0 it will come. So x by 0 is 1. So this you simplify. 6C4 will come 6 into 5 by 2 and 9 by 4, and 1 by 3 raised to power 4 is what? 81. Yeah, into 1. So you just simplify this one. Okay. So 9 9 is 81. So you have numerator 6 into 5, and denominator you have 2 into 4 into 9. So 6 can be cancelled by 2 in 3 times. 3 can cancel 9 by 3 times. So you have 5 in numerator and 12 in denominator. Fine. So look. So these are applications of general term. So you write the general term, then you see the powers of x, and they want the term independent of x. So you put power 0. If they want coefficient of x, you put 1. If they want coefficient of x square, so you put power as 2. And whatever they want coefficient of 1 upon x. So you put r as minus 1. I mean the power of x as minus 1 in the general term. So do you have any question regarding this question? So what we are discussing in the last class, we discussed binomial theorem formula. Okay, the expansion of a plus b raised to power n. Today I'm discussing general term and the problem based on this. So general term we are discussing actually from the beginning, right? I also expanded. So like a plus b raised to power n, it's a nc0 a raised to power n, nc1 a raised to power n minus 1 b, nc2 a raised to power n minus 2 b square, and so on. Ncn minus 1 a b raised to power n minus 1, and last term is ncn b raised to power. So what I want, this is like the first term from beginning is this nc0 a raised to power n. But if they ask you first term from the end, are you getting what I'm asking? So first term from end, the first term from end is the n plus 1th term from the beginning. Are you getting my point? So first term from end, first term from end is equal to n plus 1th term from beginning. Okay, if you count from beginning, that will come n plus 1th term. Like second term from end, you'll see it will be nth term from beginning. Third term from end, you count the third term from end. So if you count first, second, and third from end, so that will result you n minus 1th term from beginning. Okay, so in general, what will be rth term from the end? Rth term from end in general. So that will come n minus r plus 2h. If you observe, then you will fit on this formula. From beginning means, so rth term from end is equivalent to t n minus r plus 2. So t n minus r plus 2 I'm writing. This is actually term with the from the beginning. So if you encounter questions like this somewhere, like the find the fifth term from the end. So you first, suppose if they ask you fifth term from end, so you don't find T5. If you find T5, then it is actually fifth term from the beginning, but they ask you from end. So you resulted, okay, n minus 5 plus 2. So you will find T n minus 3. Okay, so you will find T n minus 3. So this will be fifth term from the end in any expression. So are you getting a point? Yeah. So try one question based on this. The question is, find 10th term from end of expansion or in expansion of x plus 1 by x raised to power 100. Tell me, what is the 10th term from end in the expansion of this? The formula you have this. Sanjay, are you getting?
Yes, sir.
Right, this is not difficult, just a formula. So you want 10th term from end. So 10th term from end. So that will be t n minus r plus 2th from beginning. Means n is 100, r is 10 plus 2. So finally you will end up with what? 92 2th term. So 92th term is what? Now you can write t 91 plus 1 if you want to apply tr plus 1 formula. So NCR, so n is 100. So it will be 100 C 91. A means whatever the first term is. So first term is x raised to power 100 minus 91. So 100 minus 91 and 1 by x raised to power 91. So that will be 100 C 91 x raised to power 9 into 1 upon x raised to power 91. So that will be 100 C 91 and 1 upon x raised to power 91 minus 9. So what? 82. So look, if you have a doubt, you tell me. So I use that formula beginning, and we have the formula for from the beginning, right?
Yeah.
Okay. So today I discussed with you. So in the last class I discussed binomial expansion, binomial theorem. So expansion, how we expand. Today's class we have seen general term. In next class we'll see middle term. Then we will solve previous year questions. So this done, this will do in next class. Okay. So I think we should stop here. So you have doubt, you can ask, otherwise we'll stop. Okay. Ana bolo bhai.
Yes.
Okay then.
Yes.
Bye. We'll meet in next class. Thank you.
Okay, thank you, sir.
Right. Thank you so much.